Hello everyone. Welcome to this session of Automotive Manufacturing Processes and Technology. Myself, Vimal Salot from LJ Institute of Engineering and Technology. In this session, we will discuss two topics from the forming and shaping processes chapter. The two topics to be discussed are extrusion process and drawing process. So let's start with extrusion process. Extrusion process is bulk deformation process. It is a compression process in which the work metal is forced to flow through a small opening which is known as a die to produce the required shape and size of the product. It can be compared with squeezing of a toothpaste or a cream from the tube. It is very simple example of extrusion process. Now let's see what are the types of extrusion process. So broadly, this process can be classified in two categories. First one is according to physical configuration and second one is according to working temperature. So according to working temperature, there are two types. First one is hot extrusion process and second one is cold extrusion process. And as per physical configuration, extrusion processes are classified in two types. First one is known as direct extrusion. It is also known as forward extrusion, whereas second one is indirect extrusion and it is also known as backward extrusion. Let's see each process in details. Direct extrusion process. So here the setup is shown in this diagram. It is a half sectional view of the machine setup. So it consists of a container. It is container. This part is known as a ram or a plunger, which is used to pressurize the hot billet. Billet is shown by this green color. The front portion of this ram or plunger is known as dummy block. The die is shown by this red color. At the front part of this die, this part is known as die backer, which is used to support the die. Now let's see how the process occurs. So first hot billet is placed inside the container. This hot billet is pressurized with the help of this moving plunger or ram. So this ram will force this hot billet in this direction and it will come out through the opening of the die. So as per the die opening, the diameter of extruded part can be produced. Now here this billet is hot and there is movement between the billet and the inner walls of this container. So there will be friction in between two these surfaces. So high force is required. And for this purpose, this dummy block is provided. And sometimes oxide layer is also used to minimize the friction in between the hot billet and container walls. So it is known as direct extrusion or forward extrusion process in which the billet comes out in the same direction in which the force was applied. As you can see here in this diagram, the force is applied in this direction and this extruded part is also coming out through the die opening in the same direction. How you can draw the diagram? So it is a simplified diagram of the process. In diagram, it is necessary to show each part of the setup. So here you can see the container is shown by this brown color. The moving ram or plunger is shown by this red color. Force is applied on this plunger in this direction, so it is shown by this arrow. Hot billet is shown by this blue color and die is shown by this gray color. When force is applied to this billet in this direction, the extruded part comes out in the same direction as it is shown here. So it is a final product. Next process is indirect extrusion process. It is also known as backward extrusion process because the applied force and the direction in which the extruded part comes out both are opposite to each other. And in this process, the ram used is a hollow. Let's see the setup and the process. So here it is a half sectional cross view. So we can see the inside detail of the process. So it is the outermost container in which this hot billet is placed. At the end of this hot billet, it is a baking die or baking disc. At one end of this container, it is a baking disc. Hot billet is shown by this green color and it is a ram or plunger, and you can see here it is a hollow type. The die opening is shown by this red color. Movement of the plunger and the movement of the extruded part both are shown by this arrow. So movement of the plunger is shown by this white arrow. It is moving in this direction. From diagram you can see how it is moving, and as it is hollow, when it applies the pressure or force on this billet, the billet will come out through this die opening. So it is an extruded part which is coming out in the opposite direction to the applied force. So depending on the opening or the diameter of the die, we can obtain the diameter of the extruded part. So it is indirect extrusion. How you can draw the simplified diagram of this process is shown here. So it is a outermost part which is container. Billet is shown by this red color. Plunger is hollow, so it is shown by this lines here. It is a hollow plunger, and die is shown by this blue color. So force is applied in this direction, and in the opposite direction the billet which is shown by this red color is coming out. So both are opposite to each other. Next process is cold extrusion, or it is also known as impact extrusion process. Here the billet is used in form of a slug or a blank. So by using punch and die, first blank is cut as per the requirement. So setup is shown here. It is a die, it is blank or a slug, and it is a punch. These plates are known as stripper plate. So this blank is placed in this die and high impact force is applied through the punch on this blank. So it will take the shape as per the shape of this die and punch, and it will come out with the punch. The obtained part or the required part can be separated from the punch by using pressurized air or by using this stripper plates. So it is known as cold extrusion process, and it can be applied to the material which is having high ductility and soft in nature like lead, tin or aluminum. Next process is hydrostatic extrusion process. As we have seen that in case of direct extrusion process or indirect extrusion process, there is a frictional force in between the billet and the container wall. So to minimize this problem, hydrostatic extrusion process is used in which fluid is used in between billet and the container wall. So billet doesn't remain in direct contact with the container walls. So here in this diagram you can see this billet, which is shown by this dark green color. It is surrounded by the fluid, which is shown by this blue color, and it is a ram or plunger which is moving in this direction. The die is shown, it is shown by this red color. So you can see here there are two oil seals, and the billet is surrounded by this fluid. So pressure is applied on this fluid, and by that pressure of the fluid the billet is coming out through the die opening. So there is no direct contact between billet and container wall. By that way we can minimize the frictional force in between container walls and the billet. As we are using the pressure of a fluid, it is known as hydrostatic extrusion process. It is simplified diagram of this process. These two parts represents the container. Then this red color is representing the billet, and this billet is surrounded by this fluid which is shown by this blue color. Movement of the ram is shown here, how it is moving, and die is shown by this gray color. So in the direction of the applied force, force is applied on the fluid, and that force is transmitted to the billet, and billet is coming out through the die opening, which is the required extruded part. These are some of the examples of the extrusion processes. Next process is wire drawing process. It is an operation to reduce the cross section of a bar, rod or wire. So almost it is similar to extrusion process, but the main difference is that in case of extrusion process, push force is applied to the billet, but in case of this wire drawing process or tube drawing process, the pulling force is applied. So wire can be drawn up to 0.03 mm size by this process. Here general setup for this wire drawing process is shown. So this part is undrawn wire or tube. It is a die holder, and die is shown by this green color. The front part of this undrawn tube is made pointed, and it is connected to the jaw, and which is being pulled by the draw head. And in a forward step, in next step, this wire will be pulled continuously and it can be wound on a reel. So by that way we can produce the required size of the wire. Now next process is tube drawing process. So the tube which is already produced by the extrusion process, that is used for further reduction in cross section for the tube drawing process. So tube drawing process can be used without mandrel, or it can also use a mandrel. So this process is without mandrel. It is undrawn bar and it is die opening. So pulling force is applied in this direction, which is shown by this green arrow, and through the die opening it is coming out. So as per the opening of the die or the diameter of the die, the cross section will be reduced of this tube. So seamless tubes can be produced to reduce the cross section or to reduce the wall thickness by this process. This process is tube drawing with mandrel. You can see here it is a mandrel which is used. So as per the diameter of the mandrel, we can set up the diameter, inside diameter of the tube. So here in this direction, this pulling force is applied and it is coming out. It is coming out in this direction, and as per the diameter of this mandrel, it is the inside diameter of the drawn tube. It is simplified diagram for the process tube drawing with mandrel. So we have seen in this session different types of extrusion process and tube drawing and wire drawing process. Thank you for watching.